So, scale factor ratio, all right? So, example 1, Karen would like to find the height of a tree. Ooh, sounds like something we just did, huh? She measures her shadow to be 7 feet and the tree's shadow to be 30 feet. Karen's 5 feet 6 inches tall. Find the height of the tree. Okay, so let's draw a couple of pictures. So let's draw first a big picture, right? And a little picture. Here's Karen. There's Karen, and her shadow is 7 feet. She happens to be 5.5 because 6 inches is half a foot. So she's 5.5 tall, right? Does that make sense? Change those inches into a decimal because we got 6 over 12. 6 over 12, which is 0.5. Now the tree, its shadow is 30 feet. Here's my tree. They have to be a similar triangle for lots of reasons. One, if she's standing right next to the tree, we're going to assume, like Hunter said, we're going to assume 90 degrees, right? It doesn't have to be. This angle, as long as they're standing in the exact same spot, side by side, those angles have to be equal. We know the angle from the sun is going to be equal to the angle there. So we know they are similar by angle, sim. Okay, we know they're similar by angle, sim. We've proven it. So if we know they're similar, then their proportions are going to be the same. So we can set up a ratio. Now remember, there's lots of ways to do this. Not to confuse you, but watch, check it out. This goes to this as this goes to this. All right. This goes to this as this goes to this. All right. This goes to this as this goes to this. All right. This goes to this as this goes to this. Right. As long as you're consistent, just set it up. Right. Me personally, I always like to put the unknown on top. Makes it easier to solve. So I might go tree height to Karen's height. I might go T goes to 5.5 as 30 goes to 7. Okay. And again, I want to reiterate to you guys, there's lots of ways to set this up, okay? And the reason I like it this way, because the cross multiplication is a lot faster. All you have to do really, you don't need to multiply by the 7, you just need to multiply up by the 5.5. If you multiply it by the 5.5, t is already by itself. Bring the 5.5 up here. So t is equal to 30 times my 5.5 divided by my 7. We'll use my calculator. We'll go 30 times 5.5 divided by 7, and I get about 23.57 blah blah blah. I get 23.57 blah 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 blah. So I know my answer is 23 feet, but how many inches? How many inches? How many inches is this tree? 0.57. How many inches?
0.57 of 12.
So you multiply this by 12. So you multiply the. So you notice I took away the 23, times that by 12, and we get about 6.8 inches, or maybe about 6 3/4 inches. Pretty close to 6 3/4 inches. That's how tall my tree is. Doing an indirect measurement. Pretty easy? Yeah. Okay, example 2. The scale joint of the map is 1.5 centimeters to 300 meters. So I'm going to draw my scale. I'm going to go 1.5 to 300. Now the units aren't that important. You don't need to convert. You really do not need to convert because the conversions will cancel out anyway. So that's little to big. So let's find out. So then the distance to Union Station from the library is meant to be 6, okay? So let's check it out. So from Union Station, that's there, to the library, which is right, where's the library? There's the library, okay. So if you're to measure that distance, that's got to be 6 centimeters, right? So the ratios are easy. Always remember this. Be consistent. Little to big, right? So, I mean, obviously this is little compared to the true distance. Would you agree with that? So if you go little to big, just make sure you go 6 to, well, let's call it D for the true distance, right? I mean, or map distance to true distance, map distance to true distance, right? Super easy. So cross multiply, we'll get a 1.5. D equals 1800 because I went cross multiplied, right? Just cross cross multiply, d times that, 3m times that, divide by 1.5, divide by 1.5, 1800 divided by 1.5, and I get an answer of about 1200 meters. 1200 meters, which is I think same as 1.2 kilometers, okay? Or 1.2 kilometers, about half a mile. Easy? Thumbs up? Okay, good. Turn the page. All right, last one. So, I want to find the perimeter of these darn things, but I don't have enough information. So I have the perimeter of RST. So I have the perimeter of this one is 36, but I don't know the other sides. I don't. I just know the perimeter. And so I want to find the perimeter of this one, but again, I don't have enough information. I can't go this plus this plus this. I can't go this plus this plus this. But I know that there are ratios. The ratio between these two is going to be 16 to 20, right? The ratio is 16 to 20, which would reduce to 4/5, or 4 over 5, okay? How's that? So the ratio from little to big is 16 goes to 20, okay?
Oh, Mr. Davies, you're also missing the area.
Right, and so I got have some area there too. You're right. So hopefully, if I use my ratios, I'll be able to get both, right? Let's do the perimeter first. Thanks, Katie. So the perimeter, I can't add them all up, but I do know this, that the perimeter is also going to be in a ratio of 4 to 5. So if we go 4 goes to 5 as the perimeter of the small triangle goes to the perimeter of the big triangle, we can figure it out. As long as we have the ratios, if we have the ratios and they're similar, we can set it up. Even though I don't know all the sides, if I've got the ratios and a perimeter, I can get the other. So we'll cross multiply. 4p equals, I don't know, what's 5 times? So cross multiply, right? Cross multiply. What's 5 times 36? 180. Divide by 4. And I get an answer of 45. So the perimeter of the big triangle, is 45 feet. Alright? As long as you have a ratio, as long as they're similar, they have to be similar, and have a ratio, how big one is the other, I can set it up. Now the area, right, Katie? Let's talk about the area. Now the area is a little bit different, okay? So that's my perimeter. So if the ratio is 4 to 5, then what we're going to do is this. So 45 goes to the ratio of the area. So we've got the area of the small triangle, right? So I know the area of this one is 48. Is the area of the small triangle times the area of the big one. But I got to make one small adjustment. I go back to my notes. And my notes say, well, if I'm doing area, I need to square my ratio. Does that make sense? So I'm going to square my ratio because I'm doing area. And so really, I'm back to 16 over 25 is the ratio of the area equals 48 over 8, okay? So area, I took my ratio and I squared it because I'm going from 1 dimensions to 2 dimensions, okay? Okay, now I'll cross multiply. It goes 16a equals, I don't know what 25 times 48 is. That's a lot of, is it 1200? Thanks, Katie. Divide by 16.
75.
There we go, 75. So the area of the big triangle is 75 feet squared, okay? How's that? Not too bad? Okay, so homework today. We got lots of time. You will need a ruler to do some of the homework today. You will need a ruler because you'll actually have to measure the book to get a scale.